Hello everyone, in this video we're going to explore topic 6.1, exploring accumulation of change. Alright, before we immerse ourselves in the next branch of calculus innovation, let's start with a few questions that introduce this important idea. Alright, example number 1. The graph of f prime, the derivative of the function f is shown to the left. If f of 0 equals 0 and f prime of 0 equals 1, which of the following must be true? Alright, number 1, f of 0 greater than f of 1. Alright, so we observe that from the interval 0 and 1, right? The graph f prime of s is above the axis, right? So the function f prime of s must be greater than 0, right? It tells us that the function f of s is increasing, right? So by definition, if you have s1 greater than s2, then f of s1 greater than f of s2. Now you look at this one, we have 0 less than 1, right? Then f of 0 must be less than f of 1, right? By definition right here. So this one makes answer choice 1 incorrect, right? Now look at answer choice 2. The interval 1 and 2 right here. The function f prime of s is above the axis, right? It tells us that the function f of s is increasing on this interval, right? So if s1 greater than s2, then f of s1 greater than f of s2, right? So since 2 greater than 1, then f of 2 must be greater than f of 1, right? This one makes answer choice 2 correct, right? Now look at answer choice 3. f of 1 greater than f of 3, which means we're gonna check the interval from 1 to 3. So right here you have two intervals, 1 to 2 and 2 to 3, right? 1 to 2, the function f prime of s is above the axis, which means f prime of s greater than 0. It tells us that the function f of s is increasing, right? The interval from 2 to 3, f prime is below the axis, right? Look. So f prime of s is less than 0. It tells us that the function f of s is decreasing on this interval, right? So you look at the interval 2 and 3. The amount of decreasing behavior of the function f of s on this interval does not seem large enough to make f of 1 greater than f of 3, right? So the final answer must be 2, right here. Now let's move on to example number 2. A particle P moves along the straight path with a constant velocity of 2 feet per second. The graph of Vp of t, the velocity of the particle P at time t, is shown to the left right here. So Vt represents the y-axis and t represents the x-axis. What is the total distance the particle travels from t equals 0 to t equals 2? Alright, it tells us that the area of the square right here, right? So you're gonna take 2 times 2. You get the area of this one. That is the total distance of the particle travel from t equals 0 to t equals 2. So it could be 4, right? So it could be 4 feet. Now let's move on to example number 3. The new pop music group sensation, Sir Isaac and the Newtons, have released their latest single on all the major music streaming services. During its first 10 weeks of release, the rate of the number of downloads per week in thousands of units is modeled by the function d of t, whose graph is shown to the right. How many total downloads were purchased during the 10-week period? So basically, you just calculate the error under the curve, right? So you need to split this guy into smaller figures, right? It's gonna be like this and like this and like this. Alright. So we have 3 geometric shapes, right? The first one is the rectangle right here. The second one is the trapezoid right here. and the third one is the trapezoid, right? Now the area of the rectangle is length times width, right? So the length is 3, the width is 4, right? So we have 3 times 4 equals 12. Now the second one is the trapezoid. The area of the trapezoid is base 1 plus base 2 times height divided by 2, right? Base 1 equals 1, base 2 equals 3, and the height is 2, right? So we have 3 plus 1 times 2 and divided by 2 is going to be 4, right? The third one, the height is 4, the base is 1, and the base right here is 9, right? So we have 9 plus 1 times 4 divided by 2, right? So it's going to be 20, right? Now if you add this guy up, it's going to be 36. This one is the final answer. Let's revisit a similar situation that was represented to us back in example number 2. Example number 2, the function v of t is a straight line right here, right? Now we just change this one to a curve, so it's going to be something like this. Alright, so basically you need to calculate the area under the curve right here. Alright, so we cannot use the regular way to solve this problem, right? We would have to use the Riemann sum, which is we learned in topic 6.2. Or we're going to use the integral from 0 to 2 of f of s, which we will learn later after the topic 6.2. And it's good time to start. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.